Diluting Solutions, Part 2. So in this example, we'll ask the following question. Concentrated sodium chloride solution has a strength of 23.4%. How many milliliters would you add to sterile water? To prepare 100 milliliters of normal saline solution of 0.9% strength. So we are going to mix 23.4% solution and water to result in 100 milliliters of 0.9% solution. So how much of each do we need? That's our question. So we're going to have our concentration as our first column. Our second column is going to be the amount of milliliters of solution and if we have concentration which is so many grams per milliliter times so many milliliters, it's going to be grams of sodium chloride. Now, there's two things that we're mixing. We're mixing the 23.4% solution, which is a decimal is 0.234. How much of that do we need? Then we're going to mix the sterile water. The sterile water is 0% salt, maybe a little bit more than that, but we'll assume it's 0% salt. How much of that do we need? So that we mix them, we wind up with 0.9%, which is 0.009. 0.9% is 0.009. Now, we're told that we want to have 100 milliliters of solution. So when I take the amount of milliliters of our 23.4% plus our milliliters of water, the total should be 100 milliliters. Now, in terms of our grams of sodium chloride, 23.4% of the solution is sodium chloride. We multiply these together to get 0.234x. 0 times y is just 0. And then 0.009 times 100, of course, is just 0.9. Recall that 0.9% strength means .9 grams per 100 milliliters. So since we have 100 milliliters, there's your 0.9 grams. That third column represents grams. The second column represents milliliters. So we have two equations for us to solve here. With our milliliters of solution, x milliliters of the 23.4% solution plus y milliliters of water gives us a total of 100 milliliters. That's my first equation. My second equation is 0.234x plus 0 equals 0.9. So solving the second equation, 0.234x equals 0.9. Dividing by 0.234. The 0.234s go away. What does x equal? 0.9 divided by 0.234 gives us 3.846, call it 3.85 approximately. And then we're going to substitute that into the other equation. So we have 3.85 plus y equals 100. Subtracting 3.85 from both sides, we get y equals 96.15. So putting all this together, what does this mean? 3.85 milliliters of 23.4% solution. And 96.15 milliliters of sterile water. To result in, how much? To result in 100 milliliters of a 0.9% solution. One more example. Prepare 200 milliliters of cupric sulfate, (1 to 4,000) for use as a fungicidal agent. Cupric sulfate 5% is available. How many milliliters of concentrate is needed? So we are going to mix two things. Our goal is to mix what we have, a certain amount of 5% cupric sulfate, and what else are we going to mix? And water, to result in 200 milliliters of a 1 to 4,000 solution. So how much of the 5% do we need? How much sterile water do we need so that we get a total of 200 milliliters of that 1 to 4,000 solution? So let's think of our notions here. We start with concentration, and then we have the amount of solution, and that's going to be in milliliters. Then we're going to have the amount of cupric sulfate in grams. So we're starting with what we have available. We have 5% cupric sulfate available, so that's 5 grams per 100 milliliters. So the concentration is 0.05. How much of that do I need? I'm going to add to that the sterile water. Now the H2O is 0% cupric sulfate, we would hope. So if that's the case, 0%, we want to have Y milliliters of sterile water. Now, putting these ideas together, 5% times X, we have 0.05X grams of cupric sulfate in the first bucket. 0% times Y, 0 grams of cupric sulfate in the second bucket. Now, when we put these together, we have a total of how much? We have a total of 200 milliliters of cupric sulfate. And the concentration that we want there is 1 to 4,000. So 1 to 4,000 times 200 milliliters is going to give us a relatively small number. So the result there is 0.05, which is interesting. You'll notice we have two equations. In our amount of solution equation, we have X plus Y is a total of 200 milliliters. And then in our cupric sulfate equation, we have 0.05X plus 0 equals 0.05. Well, that's certainly easy for us to do. 0.05X equals 0.05, and X equals 1. And then we plug that in to the other equation. 1 plus Y equals 200 milliliters. So Y equals 199 milliliters. So to put this together, we need we need 1 milliliter of our 5% concentration of cupric sulfate, and 199 milliliters of sterile water to result in 200 milliliters of a 1 to 4,000 mixture. And that will conclude this lesson.